So here what is the operation? Minus 10 is the operation. After that here minus 10 value will be there. So 50 minus 10 will be 40. So here h value will be 40. Now t to e is minus 5. So t will have minus 5. U to k will have 5. Now this is the last operation which we have to perform. So d value is 5. H value is 40. T value is minus 5. And u is 5. So this and this is going to get cancelled, and this plus is going to give you answer 45. Alright everyone, so what is the correct answer? 45. So many students face doubt solving such questions, so please remember, please first try to make the tree. After making the tree, then look for the operation, otherwise it will be difficult for you all. Alright, so let's see now the next question. So see this question and try to answer. So I will be giving 1 minute. Okay, everyone? Answer this. Okay, everyone? So please think about it. Okay, so let's see this question. Consider the following grammar G with S as the start symbol. The grammar G has three incomplete productions denoted by first, second, and third. This is first, second, and third. The set of terminals is A, B, C, D, F. The first and follow sets of the different non-terminals are as follows. First of S is given to you, C, D, F. First of T is also given to you, A, B, this. Okay. And after that, first of R is also given to you. Follow of S, follow of T, follow of R is also given to you. Which of the following options correctly fills the incomplete production? So what are the incomplete production? How we will get to know? So look carefully for the option C and D. They are incorrect. Why? Because if we substitute in second, T giving CF, T giving CT, and okay, so this is wrong. Why? Because if we will take out the first of T, so what is the first of T? A, B, and epsilon it should have, but it is having C. So this is clearly wrong. Okay, and as this is there in option C, that's why we can say that C is also wrong, D is also wrong. Because of this thing, we are cancelling out C and D. Now for the second, T belongs to epsilon, T belongs to epsilon is absolutely correct. Okay, so let's verify option B now. So option B is incorrect if we substitute S is equals to FR. Yes, in first, because the first of S is what? The first of S is C, D, F. And from here, what are the values we are going to get? We are going to get D and F. So where is C? This is absolutely wrong, right? D and F we are going to get, which is wrong because terminal C is missing. So B is also incorrect from this. Now only option A is correct. Okay, only option A is correct. So if we put S, so if we put here RF, right? If we put here epsilon and if we put here CTR like this, so if we take the first of S, so it is going to get D. After that, first of R is going to get C, okay, and epsilon like this. But if we will replace this epsilon, so we are going to get the F, right everyone? So C, D, F we are going to get from this. Any doubt here in this? So you should be knowing how to calculate follow and first. So that's why A is the correct answer. Now try to solve this question everyone. Very very important question and it's a very nice question. Try to solve this. Done everyone? So I hope everyone has read this question properly. So let's try to solve this question. So a pseudocode is given to you. Okay, you have to read the pseudocode properly. All right, and you have to get the answer correct, which is specifying which of the following options are correctly specifies the number of basic block and the number of instructions in the largest basic block respectively. So this is a compiler design question. Alright, everyone. So, giving a minute more, solve this. Okay, so let's try to solve this. First, you should understand what is a basic block. So, the collection of all three AC statements from the leader to the next leader without including the next leader is known as the basic block. So, we have three steps to find the basic block. First step is identify identify the leader first. Identify the leader first. What this means, the statement of 3AC is the leader. Okay. Second is the address of conditional, unconditional go to is the leader, which is target location of go to. And the third is immediate next line of go to is the leader. So now we have to construct the basic block from the leader to line before the next leader. So in the given 3AC, 7 leaders are there. 7 leaders are there, which are 1, 3, 4, 10, 11, 13 and 15. Okay, everyone? Yes. So there are 7 basic blocks are there. So which is, the first one is B1, which is from statement 1 to 2. Second is B2, which is of statement 3. Third is B3, which is of statement 4 to 9. Fourth is B4, which is of statement 10. Fifth is B5, which is of statement 11 to 12. Sixth is B6, which is of statement 13 to 14. And seventh, B7, which is of statement 15. Okay, everyone? So the total number of basic block is 7 and the largest basic block is B3, which contains a total of 6 instructions. So that is why the correct answer here is D. D is the correct answer. So I hope you also got the same answer as mine, and those who haven't calculated the answer, so here is the explanation for them. Let's see this question now. So try to solve this question, everyone. I'm giving a minute time. So this is a operating system problem. Okay, so let's see this question. Consider the following two threads T1 and T2 that update two shared variables A and B. Assume the initially A equals to B equals to 1. Through the context switching between threads can happen at any time, each statement of T1 or T2 is executed atomically without interruption. So this is T1, this is T2. Which of the following options list all possible combinations of values A and B after both T1 and T2 finish execution? So we have to assume that the given statements are A, B, C, D. Okay, so this is statement A, this is statement B, this is statement C, this is statement D. So I will provide us a way how we can answer such questions. Okay, and we can execute the statements in any order and can preempt at any point of time. So if we have the following execution, then how are the possible executions which we can do? So the first is we can execute A, B, C, D, right? The second is we can execute A, C, after that D, and then finally B. Third is we can execute A, C, then B, D. Fourth is we can execute C, after that D, A, B, this way. Fifth is C, A, B, D. The sixth is C, A, D, B. So these are the ways by which we can calculate. Now let's understand how different output is generated when we interchange the execution order. So if we see with this particular one, with this one, if we see A, B, C, D, so in this sequence we have A equals to 1, A equals to 1 and B equals to 1. So what is the order? A, B, C, D. So this is 2, right? The A will have 2 value now. After that, the B will also have 2 value. After that, this will have 4 value and this will have 4 value. Okay? So A will be updated to A will be updated, A and B both will be updated to 4. So this is the case we are going to get, right? Second is what? So the first one, A is equals to 4, B is equals to 4. So this is what we have got. So yes, so here we have A is equals to 4, B is equals to 4. So let's see how many options are there. So A and C is definitely possible. After that, this is possible, no, because there is nowhere the case A equals to 4, B equals to 4. And here is also there is no case where we are getting A equals to 4, B equals to 4. So B and D are gone by the option elimination technique. Now we have to see between A and C. Let's see that. Then let's try to execute the second one, which is this one. Let's try to execute in this order. A, C. So first, so here A is 2, after that C. So now B will be 2. After that we are going to go to D. So here 2 and 2. So A will be 4 and after that B. So B is 2. So this is what we are going to get. So A is 4 and B is 3. This is what we are going to get from the second one. So anywhere A is 4, B is 3. Option A also has this. A is 4, B is 3. Option C also has this. So no elimination. So let's move to the next combination. This one. Now here again A. So this is now 2. After that let's move to C. So this is 2. After that let's move to B. So this will be 3. After that let's move to D. So this will be 4. So what are the value? A is equals to 4, B is equals to 3 now. This is the value we are getting. So A is equals to 4, B is equals to 3 is there. Here A is equals to 4, B is equals to 3. This is also there. So let's see the fourth one now. This one. So now C. So this B will be 2. After that D. So D will be 2. A and B both are 2. A. So here it will be 3 and here B will be 3. So A equals to B equals to 3. Which option has this? So this has A equals to B equals to 3. Do we have here in C A B equals to 3? No, absolutely not. So that is why C also gone. So we don't need to check fifth and sixth one. Why? Because through option elimination easily we got to know which are the combinations we cannot derive. Okay, so directly you can tick A option. Okay, and if you want to try 5 and 6, so we can try this. Okay, 5 and 6, more options by which we can get the answer. So this if you try, so C, so this will be 2, this will be 2. After that, sorry, this will be 2 and this will be 2 like this. After that B, so this will be 3 and D, so this will be 4. Again, A is equals to 4, B is equals to 3. This combination we have already seen. And similarly, you can check for the sixth one also. Alright everyone. So I hope you got the idea how to solve such questions. Answer this everyone now. So what will be the answer? So this is the easy question which you can attempt for. So waiting a minute more. Okay, let's see this. An array 82, 101, 90, 11, 111, 75, 33, 131, 44, 93 is heapified. Which one of the following options represent the first three elements in the heapified array? So let's try to make the tree. So normal tree if we make 82, after that 101, then 90, 11, 111, 75, 33, 131, 44, 93. So this is heapified already. Which of the following options represent the first three elements in the heapified element? So what are they? Okay, first three element. So Heapify node with 111 value. If you do that, so we have to, yeah, so we have to heapify this. Okay, now if we try to change this, so now in this, what we can see, so out of this two, 101 should be here and 82 should be here. Out of this, 111 should be here, 82 should be here. And out of this two, 93 should be here, 82 should be here. Right, everyone? And out of this, 131 should be here and 11 should be here. And out of this two, 111 should be here and 131 should be here. And out of these two, 131 should be here and 101 should be here. And this is perfect. So what is the new values we are going to get? Okay, so new value is 131. After that, yes, so out of this two also, 111 should be here and 101 should be here. So after that, 111 we are going to get, 90 we are going to get, 111, then 10, wait, so 111, so 131, 111, 90, then 101, then 93, after that 75, 33, then 11, 44 and 82. So what are the first three values here? Can you tell the first three values? So these are the first three values. So what is the answer? Clearly D is the answer in this case. I hope you also have solved this way. Okay. Now let's see the next question. So try to solve this, everyone. Try to solve the recurrence relation and get the answer for this one. By Master's theorem you can solve, or by substitution also you can solve. There are two ways to solve this problem. Any of the way you can pick and solve this. So let's see how to solve this problem. So first you see by Master's theorem, if you try to solve this, so what is the answer you are going to get? So this is the equation we have. This is the first approach. So whatever approach you like, you can solve. So you can divide this by n so that here we can get 1. This is the approach which you can follow if you like. Otherwise, there is the next approach also I will be teaching. So let's divide this by n, this by n, and this by n. So the answer we are going to get is like this. So here this will cancel and this will comes up to be 1. And rest everything will be the same. After that, s of n we are going to consider s of n, where t n by n will be there. So simply can we write this as s of n equals to s like this plus 1. Okay, this is what we can write. After that, we can change n equals to, which is 2 to the power k. This we can do n, right? So this we can write this as s 2 to the power k equals to s 2 k by 2 plus 1. After that, q is equals to k and q is equals to k by 2 plus 1. So according to Master's theorem, which is the rule we are going to get from this? So here we always have this forms. So n log b by a. So here n log, so b will be 2 and a will be 1. So this is 0, n0 is 1, and this one is exactly equals to 1. So the property here we are going to apply is when they both are together, the function. Okay, when the function is together, we have to apply an additional log there. So here the answer will be like this. So q k theta of log k will be there. So what is the k value? We have to update that now. So s 2k equals to theta of log k will be there like this. And after that, from here, so this is how you can convert. S of n is equals to theta of log n. Okay, and finally if you will write the value, so t of n, so this is all substitution, n log of log n, like this, as simple as that. So this is the first way by which you can solve by Master's theorem. Okay, this is a little bit tricky, but you have to, if you will practice such questions more and more, so you will get how to solve this question very quickly. And the second is substitution method. So let me tell you the substitution method. So substitution method is like this: t n root n t root n plus n. After that, t n root n, again we are going to substitute. So n 1 by 4 t n 1 by 4, okay, plus n by 2, and this plus n, like this it will be. After that, if you will solve this, so n 3 by 4 t n by 4 plus n, okay, which is n 3 by 4 t n 1 by 4 plus 2n. Then n 3 by 4 n 1 by 8 t into the power 1 by 8 plus n 1 by 4 plus 2n, like this. Okay, and so what is the final answer? N 7 by 8 t n 1 by 8 plus 3n. And if you will substitute this more, so what you are going to get? N 1 minus 2 to the power. So this is simply n 2 to the power 1 minus 1 by 4, or 1 by k we can say. So this is simply 1 minus 2 to the power 1 by k. Okay, because 1 minus 1 by 8, so this is what we are going to get. 8 minus 1, 7, so 7 by 8, and 1 minus 1 by 8, how are we going to write? 2 to the power, because this is 2 to the power 3, like this. Okay, so this will be like this. Alright, everyone, this is the way you will write. And the inner one, you will write 1 by k. So t n, so 1 by 2k, like this you will write, plus k of n. So as many as time we are proceeding, that are we going to get. So this is totally we want 1. That means n 1 minus 2k we want 1. So after that 1 by 2k, this will be log n. Then simply if you will take the value of k, so k will be log of n, like this. So and we wanted the value of k. Okay, here k into n it is there. K into n is there. So basically it will be n into log n, like this. So what will be the answer? The answer is A, n log n. Okay, so by substitution it is a little bit lengthy, but finally you can get the answer. So please see this carefully, everyone. Please see this carefully, everyone. Okay, let's see the next one now. Try to solve this. Okay, so let's solve this. Consider a binary min-heap tree containing 105 distinct elements. Let k be the index in the underlying array of the maximum elements stored in the heap. The number of possible values of k is. So you have to understand, first point, a binary heap is a complete binary tree. Second is a binary mean heap satisfies mean heap property. Okay, so what this says, this implies that the maximum element can be in the leaves only. Okay, so number of internal nodes in 105 element heap is, which is the floor of this 105 by 2, this will be 52, And number of leaves, if we want number of leaves, so which will be 105 minus 52. So this will comes out to be 53. So the answer is A. Okay everyone, the answer is A. I hope you got the solution. So please try to solve this question now. So this is an algorithm question. Let G be a directed graph and T be a depth first search spanning tree in G that is rooted at a vertex V. Suppose T is also depth first search BFS tree in G rooted V. Which of the following statements are true for every such graph G and tree T and tree T? So we will take one example so that you all can understand by that example. So we are going to take A, B, C, E, D like this. So this is so how to create BFS from this? BFS tree will be created like this. A to B, B to D, D to C, and after that, so we have to come back to C, D, and from D it will give you, from B it will give you E. And how the edges will go? So this is going to go like this, and after that a back edge from C will be there and an edge from E will be there. This will be the case. After that, DFS, how to write? So A, B, D, they are asking for tree, right? And C. Again, E will be here. A back edge from this will be like this. And E will be like this. Alright, everyone. Then, see. First thing is back edge is there, cross edge is there. But one thing you can find is all edges not in T. So this is the T which we have created. So all the edges in T are not there. Okay. So let's verify the option. There is no back edge in G with respect to the T. This is not correct. Not always correct. There is no cross edge. Clearly we can see cross edge back edge. So not correct. After that, the only edges in G are the edges in T. So this is also not correct. There is no forward edges in G with respect to the T. So this is correct. Because forward edge cannot be there, else it will not give as same as BFS and DFS. So why are we going to get BFS and DFS same? Because forward edge is not there. Okay. So in directed graph, DFT can have tree edges, cross edges. So this point you can remember from this question, the concept in directed graph, DFT can have First is tree edges, second is cross edges, third is back edges, fourth is forward edges. Okay, and DFT can have first is tree edges, second is cross edge, third is back edge, but it cannot have forward edge. So as in DFT we don't have forward edge, so that is why it is as similar as BFT. Okay, so that is why the graph G having tree T such that it is BFT and DFT. So forward edge will not be in G with respect to T. So D can be, we have easily eliminated by the graph itself. Okay, so that is why C is the only option which is absolutely correct here in this question. Alright everyone. So solve this everyone. So here are more questions that we can solve. Okay. Solve this everyone. So here is first you have to make the transactions here, and after that with the transactions you will be making the diagram. Okay, so with the transactions you can draw T1, T2, T3. After that R1 of Z, W1 of Z, R2 of X, W3, R3 of Y, W3 of Y, R2 of Y, W2 of Y, W2 of Y. So if you got some idea, okay. So this is the homework question. Comment it below how we can solve this question. Alright everyone. So there are many questions of 2024 which I have solved. So please do check the channel videos where you will get the helpful solutions. Alright everyone. And many more such problems we are going to solve, and comment it below whatever the topic you want to learn. So if you feel that you are weak in the topic area, so please comment down below in this particular video so that I can see and I can make the video about it. Alright everyone. So all the best, keep practicing, and make sure that you are practicing the right resources. Thank you so much everyone.